Districts. Every city needs districts. One area might be suburban, another commercial, another industrial, and they should have different buildings under different rules, different setups, different driveways. And so for our city, we need to include the same thing, which is why I've created the system. Here we have just districts designated by just splines that we've put out top. They're technically just not just splines, but you can see here, this is the area that's designated for downtown, like as our tall buildings. We can move this out of the way. You can see now we're just spawning in here. Move it closer, we get more of them, and we can adjust each district and its position, how many buildings there are, how big it is. And not only that, in the detail panel here, you'll see every district comes with its own grammar, its own modules that you can set up, its own building scale, its own spacing, as well as its own driveway controls. And not only that, but whenever you make any kind of changes, like changing the spacing to, let's say, 100 from 75, you can see in the top left, we get a new print string that is just telling us how many buildings are there actually currently being spawned, so you can adjust the values and get immediate feedback on regeneration. How many buildings are there, and is the change that you made good or bad in terms of actually adjusting spawning and density of your buildings? As well, we're going to get into a few little small things and general cleanup, of course, of the graph as we continue on. But enough about that. Let's get into the first thing I want to discuss. The first thing we got to talk about is the fact that PCGEx is back on Fab. That's right, everything is back, including all the way to 5.7. So now you can easily get it where you did before, and we can continue using Fab, which is great. Hopefully next time Tim decides to update PCGEx, Fab will actually update it in a more quick manner than this one. Fingers crossed. But if you do decide to use this one, just don't forget to remove the plugins folder that you added to the project previously, and that way you're using the engine version. And then make sure when you go to edit plugins and search for PCG, you still have the PCG Extended Toolkit enabled, the regular PCG, and the Geometry Script Interrupt enabled. The first time you do this, when you swap from the plugin folder-based one to the actual integrate into the engine one, PCGEx does get disabled. Make sure you confirm that it works. I mean, to be fair, also, you will immediately notice when things are broken in your setup, most likely as well. This is a good check. Now let's go over how we're actually setting up the districts. We're making splines that we're going to be able to specify the actual district locations on. So that way, if you have uneven roads, you can specify that you want a specific section to be one district, half of a road, a full road, etc. So because of this, we're going to be setting up the splines, and we're going to be migrating a lot of the functionality that we have currently on the PCG side in our main graph. So if I select this, you can see all of this modules, building scale, spacing, grammar, driveway mesh, and the road half width, which should really be renamed. All of this is going to be moved to the spline. So that way we can use the splines information instead of having it directly on the PCG graph itself, so we can control it per section. Now, while I am setting this up for my city gen, I will do my best to kind of explain what I'm doing, so that way if you have a separate setup or different setup for yours, or in general want to use it for something else, you kind of understand what I'm doing and why. So let's get started with just creating the spline first and setting that up. So the first thing we're going to do is right click, go to blueprint class, and select of a type actor. I'm calling this BP_city gen district spline, and I'll open it up. In terms of the components, we just need the spline, so I'll go ahead and hit the add button, search for spline, and we'll get ourselves a spline here, and then we'll just drag it out, just like so, and then in the detail panel, search for close, and turn it into a closed loop. Now, depending on your setup, if you have a more of a grid setup versus a more organic one, you might want to go to select spline points from the right-click menu, select all spline points, and then right-click again, spline point type, linear. If you have a perfect grid, this might work better for you. It really depends on kind of your setup and your needs. You can always change these points types at any time, so don't feel like you have to make your decision right now. But yeah, we have this, so this is good. We just need the variables. And the variables that we're bringing over is basically anything we want to control. So right now, under buildings here, we have modules, building scale, the extra spacing for the buildings, the grammar logic, the driveway mesh, and the kind of the gap from the road. All of this effectively are district. So I want to move all of these variables here. Now, unfortunately, you cannot just right-click, copy, and paste. You can do that blueprint to blueprint, but it does not work PCG to blueprint. So we have to add them back one at a time by just going to the variables, adding the one you want, for example, modules one, and then searching PCG module, grabbing our mode mesh module info, then right-clicking to make it an array, making it exposed by hitting this eye icon. And this is very important. Make sure all of these variables have the eye icon open, so they are exposed. And then if you'd like to, you can then put them into a category. For example, I'll put mine in one called buildings. And basically we need to just recreate these, set up the defaults on these, like on the modules. We need to set up some basic mesh, basic basic symbol, A, and turn on use mesh bounds as module size on. Basically, we're recreating these settings here on this one. So I'm going to do all of those, and I'll be right back. So here we are. I have the district grammar, the modules, building scale, extra spacing, driveway mesh, and I renamed the last one, which used to be our road half width. To make it make more sense, we just said I'm just calling it shorten driveway by a certain distance, because it goes all the way to the middle of the road, and we might want to adjust it based on the thickness. Right now, we're assuming all the roads are the same thickness. Down the line, we can look into having different thicknesses of roads, like a 2-lane, a 3-lane, etc. CityGen is extremely complicated. There's so much that goes into it that's not really possible to do everything in one go. So we'll take it little by little. If that is something you want to see next, though, let me know in the comments below. So with all of this put in, we can go ahead and just compile save, and we're kind of good with this spline. Now we can go here into our world and just drag out our spline, and we have made it way too small, so that's okay. I'll just make sure and drag it out and make it a little bit bigger. Okay, so here's the splines, but they're all on the ground. I want them kind of actually in the air because it'll be easier to manage them this way. So I'll select all of them and kind of move them up. You still want to keep them inside of the bounds of this volume. So just keep that in mind. Keep it still inside the volume. If needed, increase the size of the volume. We'll just put it like up here. That seems good. And you can see here in the detail panel, there's our building section, there's our driveway section. And with all of them still selected, I'm going to set some of these values up immediately. I'm going to set the building scale to 10. I'll increase the extra spacing to something like 100. I'll put in the driveway mesh by searching for driveway and grabbing my X forward version. And the shortened driveway by is fine. The only thing else we need to do is customize each one to have at least one unique building per. And that's what I'll do. I'll select each one individually and I'll swap out the static mesh for the module. And I'll keep the district grammar right now just on using one random one, but keeping it as A in curly brackets with an asterisk. So for each one, I'll just go ahead and swap this static mesh, go to the next one, swap it with a different one, swap it with a different one. And just for fun, on this last one, I will add one more. So we'll go between two. We'll set the symbol for the second one to be B. Use mesh bounds as module size will be on. And since we called it B, I'll call this A comma B with the asterisk at the end. There you go. So this is now all set up. Now that we have these district splines all positioned, what we're basically going to do is look at all of these splines and see where they intersect with different sections of this, well, city, I guess? It's not small of a city, but our little mini city here where it intersects. And then based on where it intersects, it will keep only those points from each district and then spawn things accordingly from there. Now, if we go back into our actual CityGen, the way we're accomplishing our current spawning is through this subdivide spline that takes a singular grammar in. Now, unfortunately, this node here will always use the first piece of grammar that goes into it. It doesn't matter if you want to try to put in multiple, you'll always use the first, which means the only way to get it to read multiple grammars in multiple areas is to do a loop. So what we're going to do is set up a loop that looks at all of our districts, finds what intersects, keep those points, and assign the grammar that we want from the spline that we're getting it from. So instead of getting it from the regular PCG graph, it is now going to get it from that spline, which means we first need to sample the splines of the district. By splines, I really mean the actors of the district. So I'm going to go a little bit below this section where we have the subdivide spline with the grammar set up here. I'm just going to right click, get spline data. Instead of self, it'll be all world actors. We're going to do by class this time, and we're going to plug in the actor that we created, the CityGen district spline. We're also going to make sure it selects multiple. So select all of them, and let's go ahead and sample it. We'll use a spline sampler. I'm actually going to sample it. Instead of on spline, we're going to go on interior. Now, I don't need it to be very exact. It could be roughly the correct amount. So I'll set it to be 1,000 and 1,000 for interior sample spacing and interior border sample spacing. I'm going to press D to check, and you'll see there's our points. Now, they're up in the air, and we need it to be kind of down all the way down here where the road is. So to fix that, we could just use a bounds modifier, and I want to transform the bounds min in Z. So basically, how much do I want to scale it? If I scale it, for example, by 50, because it's set to scale here, it will scale the minimum, so down 50 in Z. So if we take a look at that, you can see that is 50 times bigger in Z down. So if I wanted to, I could move this spline even higher and be fine. But watch out, don't make it go outside of the volume entirely. It still needs to be inside the volume. So depending on how big your volume is, 50 might be what you need, or you might be able to get away with something like 30. It all depends on how high you want to position these splines. The higher up you go, the further the distance down, the further you need to have the bounds modifier be. But effectively, this is now encompassing our entire area. Perfect. So now we know where these areas are. Now we need to get the information from these areas. So all of those attributes that we kind of added, we now need to get and assign them back to these points. Because if I pressed A here, it has all the point information of the spline, but it has no attributes whatsoever. You see here, it ends on seed. But we can get that information. If we just right click and do get actor property, we can do all world actors just like before, by class, the same class, select multiple, and by leaving property name on none and pressing A on this, you can see there's our district grammar, building scale, extra spacing, our driveway mesh, and the shortened driveway by. Which are these variables here? Now you might notice, wait, there's 6 here, but only 5 are here. We're missing modules. Modules is an array. And as of 5.7, you cannot just pull in a full array along with everything else on a single attribute, but you can still pull in an array. All we need to do is just duplicate this. And here we need to specify the property name. And when I type in the property name modules and press A on the get actor property for this one, you will see there's all of the properties that go into that array. And by array, it's really an array of structs, which is why we have multiple information. So there's all the variables of that struct, and we have more information than we have multiple things like an array here. So awesome. So I'll actually add a little comment for myself. This is going to be our modules, and this is going to be our single variables. So the single variables one, we're going to match and set attributes. Basically, assign all of these variables that we got from the actor onto these original points. So if I press A on these now and scroll to the right, you'll see there it is. The district grammar, building scale, extra spacing, all of this was applied to all of these points. Fantastic. And the main thing here is you can see there are 4 data sets. Just like on this one, there are 4 data sets and they all correspond. So the first piece of data is the first piece of data of the other one. Nice and convenient. Now in our case, we don't actually want to combine the module one with the others because we'll be using the modules right over here. So basically all of this here, over here, and all the way going all the way here, and this, including this create spline, is all going to go into a loop. Because based on of these districts, we want to do the separate grammar system for each. Now, it is possible to right click and collapse to a subgraph, but I have found that for whatever reason, there's a slight bug right now. It might have existed before as well, where if you do this and you remove some inputs, you will still see them when you drag this graph into your PCG graph. So you have extra ghost inputs basically. So to avoid that, we will create the base loop parameters for in and out, and then copy what we need into those and plug that in. So let's do that. I'm going to right click, go to PCG, PCG graph, empty graph. I'll call this PCG loop underscore grammar by district. And then with it selected, I'll drag it in, create loop grammar, and double click to open it. So over here for the input, the first set of points is street points. So these are the points that come in as from your street, the main graph. It is set to required and to allow only points. It is not a loop. But the next one is the district points that we just created, which we are going to loop on all the district points. It is set to allow type points, set to required. And the final one is our modules set to attribute set because it's an attributes that is also set to required. And the output is just a simple point output set to pin status normal. I always like to set required for the inputs because I don't want anything breaking if we don't send a value through. So with this now created, we can go back to our CityGen and plug things in here. So our modules here are going to go into the modules. Our district points are the ones from here. So we can plug those in. I'll go ahead and just select all of this and comment this to sample district splines. And the thing that goes in here, right, as I mentioned, is pretty much right here, right before the create splines. Now this one's throwing a warning. Don't worry about that. Just some inputs have less than 2 points and won't be processed. It's just a heads up. Depending on how our splines are arranged, we might have a road that's too small, so it cannot do its normal thing. Totally fine. We can adjust our roads. That's not a problem with the graph itself. I'll go ahead and disconnect this conversion node after the difference, and then I will take this, bring it over here, and plug this point conversion into street points. So it's our cut splines that we've offset and cut out any unnecessary pieces. So now let's go ahead and grab what we need here. So again, we're going to be taking the subdivide spline, the grammar, and all of this. I'm going to take all of this here, select all of this. I'm going to just cut using Control X. We're going to go into our loop, go down, and paste. There we go. So now we can start hooking things up. The first thing I want to do though is make sure that we're only working with the points that we need. So from the street points, I'm going to use an intersection, and I'm going to check that it is intersecting with the district points. If it is intersecting, so those giant columns of points basically that we made, if it's intersecting, then go ahead and use it. Otherwise, ignore all the rest. We don't care about them. So awesome, we're going to keep only those. Then eventually we're going to go and create our spline. So we need point type, and we also need to have the grammar already on the points because we're not going to grab it separately, although you could. I'm going to show you how to do it separately just because we've done it through an input before. So what I'm going to do is just convert to point. So we're working with points again here. And we're just going to add the grammar attribute. So we're going to add attribute. And as always, we want the parameter version. And now we need to grab the information. Now the information is all coming from these district points. So from here, we can go ahead and just grab a get attribute from point index. And because of the way we've assigned the points, all of them have the same information. So we can get the first index. It doesn't matter. We just need to specify that we want the district grammar here. And when you press enter here, you should see no errors if you spelled it correctly. And if I press A on here, you should see there's our district grammar, AB. And if I change the loop here, then we will have different results, AB. Now, there's errors and warnings on this. That's because we have errors here, so don't worry about all of this displaying red. It's kind of expected right now with things not fully set up. Main thing is we can just take this attribute and plug this in, and then I can change the name of this add attribute to something like grammar string. Then we can go ahead and just take all of this, just move it over. That's going to go into the create spline. It is going to complain on the subdivide spline here. That's because we're still plugging in this grammar. Let's go ahead and get rid of that. Select the subdivide node, and we're going to specify grammar as attribute. The attribute that is a grammar string that we created right here. So we're going to specify grammar string, but we have still a warning. Unmatched token font for grammar A. That's because we still need to plug in the modules. So let's go ahead and do that. I'll actually move this part all the way back because we need to grab the module information here. So you just grab the modules, take them and just plug them into A. We can delete this one, double click to add a reroute point and plug into A and B here. So basically we're just taking the modules here and plugging them directly where they used to be. When we do that, you can see the subdivide spline is no longer complaining. Fantastic. We still though have the building scale and the extra spacing to adjust. We can get those just like we did the other one. We take this get attribute from point index, duplicate it from the district points. We need both of those. So I'll just add a reroute and copy this one more time. We'll have the first one here be building scale and the second one be extra spacing. Again, these are just the variable names. You can press A and you can see there's our building scale set to 10 and our extra spacing set to 100. So instead of what we had before, I can just plug in the building scale all the way through, delete the old attribute there, and the same thing here, plug that all the way through, delete the old attribute, maybe clean things up a little. But there we go. We've kind of swapped out all that information from the input. And then after the subdivide spline, we're just going out as we did before. Okay, so this is looking good. So I'm going to just take all of this that we have now, that's a little more compact, and that's going to go back into this attribute partition, which we were doing before, just like so. And if I already take a look, ooh, well, that already seems to be working. Look at that. We now have things based on district. Now it's going to be hard to tell with these two, so maybe we can move this one over here and move this one over here. And you can see we now have one section with one kind of building, another one with another kind of building. And if I want to, I can take a look at the modules on this one. Maybe depending on the buildings, I want to change the spacing on this one to maybe 150 or 50, maybe adjust things. Maybe I want these buildings to be smaller, making it scaled by 8, 6. Maybe I want them smaller because they're actually different scale to the other ones we can see here. We can already adjust this quite nicely, and it's following the grammar. Now, this one here, you can see this is a straight road, so the buildings here fit really well. Once you start going into curved roads, things don't fit as well, so you're kind of stuck with stuff like this. But we can still make improvements to this to fit more buildings in and get us information that we kind of really need to have. I want to adjust two things. I want to make more buildings fit in here, and I want to know how many buildings are there. So when I change a value, I want to know, am I improving things or am I going to make it so there's less? So let's start with that. How many buildings are there whenever I make a change? We can get this information actually very easily. Right here, after the self-pruning, that is how many points there are. Or the static pair spawner honestly is fine too. All I'm going to do is after the self-pruning, I'm going to drag out, I'm going to do a print string, and the detail panel, I'm going to select print to screen because I want to see that information and open it. And I want to know how many points there are. So I'm going to drag out of the self-pruning again. I'm going to search for get points count. However many points there are, go to the print string. So go ahead and do a print string whenever we change a value. So now if we come here, you can see 125 buildings are currently in this area. If I go ahead and let's say change this spacing here on one of these from 100 to 150, you can see 124, 100, 125, 50, 123. So with this building, maybe around 100, 125 is one extra one there. So you can see we now have 126. We can go to a different one and adjust that one. Maybe lower, no, higher. No, it seems like maybe 100 is kind of the good one here. Oh, 75 is better. We are able to fit more with 75 spacing. By the way, if I do 0 spacing, you can see we get less actually. So the extra spacing really helps, specifically more so when there's a little bit of overlap. But there is a way to increase the amount of buildings even further further. I want to make it so it's even more precise. Now for what I want to show, I'm going to go right over here. You can see that there are some buildings missing here. If I go ahead and disable the self-pruning, well, their buildings are there and they're not actually touching. They're very close to touching, but they're not quite. Yeah, I'll re-enable it. You can see they disappear, disable it, reappear. So I want to get back some of these buildings, or at least try to. Obviously, stuff like this is pretty bad, but honestly, if it's this little, maybe we can get away with it. So I'm going to go back to our self-pruning node. I'm going to keep it on precise test for this. Keep in mind, the more your districts overlap, the more the self-pruning will effectively cost in this department. So try not to overlap your districts very much, to say the least. But what we're going to do is change this primary mode to after transform. Expend bounds after world transform. So whatever modifications to bounds we want to do it after the scale. If we did it before the scale by selecting before transform here, then our 10x scale would 10x this bounds modification. So if we, right now, let's select after transform, and you'll see we have a value primary expansion. So we can increase or decrease the bounds that it's using for this calculation. And after transform means as they currently are, basically add or subtract whatever number you want. Before transform, it's like doing it before whatever transforms you did in the past. So if you were scaling it 10 times, your value now would be scaled 10 times. It's very confusing to me, at least. Hopefully it makes more sense to you guys, but that's kind of the gist of what it works. Why is it transform instead of just scale? Apparently there's also stuff that it's doing with rotation and location. Honestly, I cannot wrap my head around, but in terms of usability, set it to be after, and it will work pretty much like you did a bounds modifier here after you've done all your transforms. It's just built into this node. So this primary expansion, I'm going to change to something like -50 to start. So I'm going to shrink it down. And when I do -50, you can see, hey, these buildings are back. Would you look at that? Now, I'll go ahead and make it 0 right now. You can see those buildings disappear. And then again, I'm going to set it to be -50. And you can see we get a few more buildings. -60. Then we got a building back right there. Let's take a look. 0. Yep, -60. Yeah, that looks pretty good. Is it touching? Technically not. But, you know, we're starting to get into the dangerous category where things could theoretically be touching at -60. Yeah, we're kind of getting into the slightly overlapping in some spots. But now we can play around with, are we okay with that overlap or not? Probably going with -50, -60 gets us kind of where we want to be. It's a little close there. But this is even with -50, it's still like this. Honestly, I think it's fine. I'm going to go with -50. And if we take a look at the top left, if I press 0, so this is with no expansion, we're at 131, and -50, we get back a lot of these, and we go to 139. So we are able to retain 8 more buildings than we did before by just pretending the bounds are just a little bit smaller. It really depends on the kind of buildings you're using. Maybe you want or not want bigger or smaller. I think -50 is pretty good from what I've played around with these kind of buildings at least. So awesome. We now are retaining far more information and we know how many we have. So if we make changes, we get the value. Now, one other thing I want to modify here is the distance at which these buildings are located. I feel like it could be a little bit closer, or maybe a little bit further. So let's go ahead and do that. Now, in my case, that is controlled here on this offset node. So it is actually separated from our sample district splines. It's possible to sample the district splines earlier and attach that information. For convenience though, since I already shown you how to do that, I'll set it up as a global one for now. Down the line, if we feel like we really need it per district, we'll go ahead and adjust. So down the bottom left, I'll go ahead and add a new parameter, press F2 to rename it. I'll call this global building offset from road. And I'll make the default 1500. And then I'll open up this offset and kind of move it up. And then I'll grab our float here, our variable, and we want to plug this into offset constant. We're not using an attribute, we're using a constant. That's where we plug it in. And as simply as that, we can select our entire graph here, go down to global building offset from road, and change that from 1500 to, let's say, 1400. So we went from 139 to 134, 1200, 150, 1100, 160. But of course, the lower we go down, the more problems we run into with big buildings. As you can see here, yeah, it is closer. And for these buildings, it's good. But for the bigger ones, we're running into issues. So if we go back to like 1350, we have 142, and we kind of get away with it a little bit, even on these guys. They're kind of a little bit over the edge, but honestly, the way they're over the edge kind of connects them to the road. But yeah, over here, we run into the issue of it being a little too far. So honestly, I'll go back to the 1500. That seems to still be the best amount, but we now have control over it, which is good. If we want a little more points here, we can go ahead and expand these and adjust them. Let's say we want a little more in this vicinity. We can expand this district, maybe shrink it a little bit in here. You can see some of them have priority over others. It depends on which one you kind of placed in first. So I'll go ahead and just expand this a little more. We get a few more buildings there. And if at any point we want to have multiple different kinds, let's say we don't want just this kind of building here, right? We can go into the blueprint of that spline, open the modules, add ourselves a new entry, plug in our new building. Let's call this symbol B, use mesh bounds as module size, and we'll do A comma B for randomness between the two. And now you can see now we're randomizing between the two. We now can play around with this value again. We're at 143 with 125 spacing. We could try getting it lower, 144 with 150, 145 with 200. So we go with like 200 and get a few more buildings in there. And that's looking pretty good. You can see here, again, buildings that are right next to each other fit pretty well like this. So this is working really well. And if you really want to, you can make these actually follow along the road more closely. So that way you actually get proper separation. So you don't get like one of these building on the other side and it's more actually separated by road. On one side is one, on the other side is another, or most likely you will have a big area that is one district, another big area that's another district, and so on. The final thing I want to take care of are these graph parameters for the buildings. We're not using them anymore, so I want to get rid of them. What you can do is just click this drop down and go ahead and remove property. If you can remove it, that means it's not being used anywhere. If you do remove property and it throws this, it's still using the graph, we need to make sure we swap it. So for example, this building scale is still being used right here. Now, we don't need to use this here. We have it on these points. So to replace this transform points, we're just going to drag out, use a multiply node, and we have the out is going to go into NA and NB. And in the properties here, we're going to go to point scale, and we're multiplying it by building scale. So we'll type in building scale. And if you recall, is the building scale that we're getting from the variable here that we added right here when we sample the district splines. So multiply it here, and then we can go ahead and get rid of this transform points and plug this all the way through. And now we should be able to remove the building scale by doing remove property, extra spacing, same thing, remove property, grammar, driveway mesh, we do need to override. And that is all the way over here. We're doing add attribute driveway mesh. We don't need this anymore. So I'll plug this through all the way directly and get rid of this add attribute. And in this bounds for mesh, we need to specify the attribute we're now using, which is our driveway mesh variable we added. And here's the road half width. We also need to modify this. We can go ahead and plug in the solidify into both the first and the second input. And the subtract is going to be just like the other one, shorten driveway by. I'll actually go ahead and just copy this. And the subtract input source 2, shorten driveway by instead of this road half width. So I'll delete that. And again, remove property, remove property. So we're just left with our global stuff inside of this graph. And you'll see everything is still generating. Now this doesn't have any parks or trees or any kind, but we now have our base setup to set up districts and control different areas of the city. And I think that's a pretty good start so far. But there's a lot still to do. So let me know in the comments where you want me to go next, because we can take this in so many directions still. And by directions, I mean, there's so much still to do with a city gen. My God, this is a big project. But as always, the project files for this will be available on my Patreon, where you can join these wonderful people here in supporting what I do. It really means a lot. If you'd like to join the community, the links to everything will be down in the description below, as always. And if you missed how we got started with the city gen, check it out right here so you know how we got here, so you too can follow along and create an awesome city gen for yourself.